So Ms. Waysome was explaining to us what HCF is. So here we have the HCF of a set of numbers is the greatest factor which is common to all the numbers in the set. Ms. Waysome was giving us somewhat of an example. She was checking to see whether or not her example is correct. So Ms. Waysome, would you like to share your example with us now?
Yes, sir. I was saying for 4 and 8, and the HCF would have been 4.
So you have 4 and 8. And you said the HCF would have been 4, right?
Yes, sir. So 4 would have been the biggest number common to both.
Right. So 4 can go into itself, 4 can go into 8. So 4 would be the HCF. All right. So just to shine a little bit more light on it, I'm going to give you an example too as well. All right. So as we said, the highest number that will divide all the given number without a remainder. Example, here we have the numbers 24, 36, 60. Now you want to find the HCF of those numbers. Remember that the HCF is a factor. And if it's a factor, it must be able to go into the other numbers. So the HCF of 24, 36, and 12, and 60 would be 12. Now, is 12 the only factor that can go into these numbers?
No, sir.
No. Give me an example of some other factors that would go into 24, 36, and 60.
You have 2, 3, 4, 6,
Yeah.
and the list goes on, sir. 8.
Okay.
8 can go in some 9.
No.
So it'd have been, yeah, so it'd have been 2.
So factors of 24, 36, and 12, factors that are common to them would be factors that any number that can divide all three, right? You could start with 2, you could use 3, you could use 4, and you could try to search for factors. Now you may find that the highest one would be 12, right? So 12 is the highest number that can go into all three of them. So for that reason, 12 is the highest common factor. Now, as I mentioned, the HCF and the LCM, students often confuse the two. And sometimes you kind of get a little bit flustered with which is which. So I would suggest that spend the time and try to be able to differentiate between them so that you don't get confused when you're asked to find one or the other. All right, guys? Now, 12 is the highest factor which is common to all the number given. All right? Now, we're going to look now on power, students. Anybody can give me a definition for what? Power. Give me a definition for power. Anybody? Miss Andrews, are you still there? Anybody can give us a definition for power, guys? Come work with me, please, please. Miss Cummings, can you tell us what you know about powers?
Yes, sir.
How would you define powers?
Sir, power is the amount of time you
Not figuring it out, Miss. So when you say the amount of time, what that means. Go ahead.
Sir?
Go ahead, Miss Raysom.
Sir, the amount of time a number can be multiplied by itself. For example, you have 2 to the third power, so you have 2 times 2 times 2.
All right, so we have 2, right?
Yes, sir. Yes, sir. So that been the number of time a number can be multiplied by itself.
All right. So here is the number that you start off with 2, right? And you multiply it by itself one time here. Then you multiply by itself another time. Does that fit your definition?
Yes, sir. 2 to the third power.
No, but based on that, you would only multiply it 2 times. Following what I'm saying, Ms. Raysom?
Mm-hmm. So, sir, when you have 2 to the second power, not just 2 times 2, which is 4.
Yes, but we're talking about a definition now. So if you're saying the amount of times a number the amount of times a number multiplied by itself. So this is the
Yeah, would have left up to the power.
Yeah, but if you're saying that is the power, then here you would have what? 2 to be the power because I multiply it 2 times. Now 2 squared is 2 times 2. But that's not what we have here. We have 2 times 2 times 2. That's a different thing, right, Miss Wilson?
Yes, sir.
Hmm?
Yes, sir.
All right, can somebody else try to come up with a different definition? You can lower your hand now, Miss Wilson. What about you, Mr. Campbell? Can you come up with a definition for Paul?
So power you have a base number and I raise it to sorry for the that probably can come but base number I raise it to a exponent. I think that's what they call it. Yeah, sorry sir. I think that's what they call it. So the exponent I say you have like what Miss Wilson said, 2 to the 2 to the third power. You're gonna get we're gonna do 2 times 2 times 2 because 2 is the base number. So people usually identify it with the little small 2, small 2 beside 3.
All right, so you're describing what happened. So how would you define it? What would you say it means?
Base number multiplied by exponent. Yeah.
Let us see what you just said. Okay, you have to be careful. All right, let's say 2 is your base number, right? and you raise it to the power 2, what would this mean to you, Mr. Shamar?
2 multiplied by 2.
Right. Now, suppose you have 2 as a base number and you have 4. What would that mean?
$16, sir. Sorry. 2 times 2, 2 times 2 times 2 times 2.
All right, so 2 times 2, it coincidentally happened to be 16, right? But what I want you to be able to do is exactly what a power is. What's a power? Let me find out if somebody else can try. Miss Green, can you try to give us a definition or give us your definition of what a power is?
No, sir.
You don't know what a power is?
No, sir.
Okay. All right, so the power really, as Mr. Shamar was describing, is the number that is above the base number, and we call it the exponent. However, in terms of a definition, to say what that number is, we would say it is the, when in terms of a definition here, we say that the power of a number is the number of times the number occurs when multiplying by itself. So it means that if you multiply 3 times 3 times 3 times 3, then the number is multiplying by itself. But how many times that number occurs? It occurs 4 times. So because it occurs 4 times, we will write the base, which is the number that we are multiplying together. So the base here would be the 3. And the power here we would put up here, which is 4. That tells you how many times the number occurs when it multiplies by itself. So it occurs 4 times. So we say that the power is 4. All right, so that's basically what the power means. Now, we may use other words to describe power. We may use, anybody can tell me which other word we can use to describe the power? Instead of calling it power, what other word we could use?
Exponent, sir.
All right, exponent. Everybody agree? And there's also another word that we could use apart from exponent. Can somebody tell us? Anybody know any other word apart from power and exponent? Which other word we could use? Nobody seem to know any other word? Mr. Adrian, are you hearing us?
Yes, sir.
Do you know any other word that we could use to describe power?
No, sir. Belong to this one.
Have you ever heard of the word index or indices? So the word index means the same thing as power. All right, so here we have, if a number A multiplied by itself occurs 6 times, then the power of A will be 6. and we'd write A as the base number, and the power would be 6, which tell you how many times it occurs when you multiply by itself. So the power is also called index when you're dealing with a singular power. And if you're dealing with more than one power, which is now plural, we call them indices. Is it the first you're hearing the word indices, students? Anybody ever heard?
Yes, sir. First, may I hear it?
Anybody ever hear the word indices before? Raise your hand, let me see if I've heard the word indices before. Let me see the hands of those who are just hearing that word for the first time. All right. All right, so we know that we can use the word power. We can use the word exponent, or we can use the word index. They all mean the same thing. All right, so next we want to look at what a sequence is. Anybody know what a sequence is? Miss Green, have you ever heard the word sequence before? Or in mathematics?
Yes, sir. I do.
What it means?
Quite remember, sir. I think it's the amount of time it. Sir, I don't remember.
Okay. All right, what about you, Mr. Arthur? Mr. Arthurs? Mr. Arthurs, are you there? All right, so have you ever heard the word sequence before? You know what it means? That question is for you, Mr. Arthur. Mr. Arthurs. Ms. Andrews, are you there?
Yes, sir.
All right. Did you get to any of your group members?
No, sir.
Okay. All right, so you ever heard the word sequence before, Mr. Arthurs? Not Miss Arthurs, I mean Miss Andrews.
Yes, sir.
Okay. And what does it mean?
So I don't really have a, a full explanation, but is it the arrangement of numbers in a particular order?
All right. It's not, well, it follows an order, but it has really not so much to do with arranging them. But the order comes out of doing something. All right. Anybody else would like to shine some light on it? Miss Waysome?
Sir, I would have said the same thing as the young lady said just now, the order in which, numbers may flow or the pattern it follows.
All right, so a pattern would probably more describe it. Because when you have a sequence, you have a series of numbers that follows, or a sequence of number following one behind the other. But the numbers that will come out behind each other will obey a certain law or principle. All right. So if I am saying to you that what would be the law of 2, 4, 6, 8, 10? What would be the law that give us those numbers in that sequence?
Even numbers, sir.
Well, apart from what we call them, how do we get them?
Keeping a number, alternate numbers.
All right, so you could write, so you could use that as a pattern, skipping a number alternatively, but you would have to start off with 2, right? Now you could also think of any other law that you could use. I mean, you have various laws that you can use to form sequence. So in essence, this is what a sequence is. It's a set of numbers which are connected by some definite law. And so, for example, you have 2, 5, 11, 14, and the law that these numbers follow is the sequence of adding 3. So as you move along from the first number going up, so you start off with 2, then you add 3, you get 5, then you add 3, you get 8, then you add 3, you get 11, then you add 3, then you get 14, and so on. Now, you can always come up with a different law. Now, it is not just adding, but you can use any kind of operation to come up with a law. You could use the law of subtracting. You could use a law of multiplying. You could use a law of finding the square root. But whatever the law is, whatever you do to the first number, they apply the law to the first number, and apply the same law to the second number to get the others that follow. Is that clear, guys? Is everybody clear on what a sequence is? Raise your hand if you're understanding what a sequence is today. Okay, all right, good. All right, so now that we have looked at these four words, factors, multiples. All right, so Mr. Javon, are you hearing me now, Mr. Javon? Okay, all right. Did you have any question that you would like to ask? Or do you have any? Mr. Javon, do you have any question you'd like to ask? All right, so based on what we have just learned, so we learned about factors, we learn about multiples. You must be able to differentiate between what a factor is and what a multiple is. You learn about LCM, which is the lowest common multiple. You learn about HCF, which is the highest common factor. Okay. So as I was saying, Mr. Javon, a sequence is a set of numbers which are connected by some law. meaning that you start off with the first number and you apply some law to it. In this case, we are applying the law of adding 3. So if you add 3 to 2, you will get 5. Then you add 3 to 5, you will get 8. And you add 3 to 8, you get 11. You add 3 to 11, you get 14, and so on. Now, I was also saying that you can have other laws apart from just adding. So the law will involve doing some kind of operation. So you could be subtracting, you could be multiplying, you could be dividing. Sometimes you may even use 2 laws doing one sequence. Probably you can add and multiply a number same time. So let's say you're adding, let's say that you're multiplying the number by 3 and then you add 1. That could also be a law or a pattern that you use to derive the numbers. Is that clear to you now, Mr. Authors? Okay. All right, so you should all have an idea of what these mean. All right, so I'm going to move on to another slide. So I'm going to stop sharing this one and start sharing another. And our next slide here, we're going to be looking at decimals. All right, so we would have looked at, from the number system, we looked at different types of numbers. We know the various types of numbers. We have counting, whole numbers, integers. We have rational, irrational, and all of those together make up the set of real numbers. And what we have done was to carry out the 4 basic operations on each. So we would, if we talk about counting numbers, we would learn to add them, subtract them, multiply them, and divide them. Now, that is what you would mostly do from primary level. Now, if you look at whole number, you would basically notice that whole numbers and counting numbers are pretty much the same, except for the addition of a 0 to the set of counting numbers. So the whole numbers would include all the counting numbers plus 0, whereas the natural numbers or counting numbers would just start from 1. You wouldn't have any 0 in the set of counting numbers. So if we are carrying out the 4 basic operation on numbers, we would have carried out our operation on remember we looked at integers, and we remember we looked at fraction. What kind of number, what type of number is fraction, students? Fraction is what type of number in terms of the number system?
Rational numbers, sir.
Rational numbers. And we know that rational numbers can be expressed in a numerator and a denominator. Now, can somebody tell us something that you know about decimal? What do you know about decimal, Ms. Wesa?
Sir, move to someone else, please.
All right. Ms. Green.
No, sir.
No, sir. All right. Mr. Ojeno. What do you know about decimal, sir?
So we know the decimal have point in it and it start from 10. From 10.
Okay. All right, Miss Trivia. What do you know about decimal? Are you there, Miss Trivia?
Sir, I don't remember anything about decimal.
Say that again. Say that again, Miss Trivia. Didn't get to hear what you said. All right, I am not sure. Maybe you're not hearing me so clearly. All right, go ahead now, Mr. Campbell. Tell us what you think about decimals, what you know about decimals.
So, sir, the other thing about this, I think decimals are like fractions, but just in number form. You forget what I was saying.
In number form. All right, so I would say that there are special types of fractions. Yes, there are special types of fractions. What make them special? Can anybody say why they are special?
Because they may consist of a whole number and a fraction.
Well, remember when we were looking at fractions, we have mixed numbers or mixed fractions that have a whole number part and a fractional part. Everybody remember that? And so I think that's what Ms. Trivia is saying, that you have a whole number part and a fractional part. That's what you're saying, Ms. Trivia?
Yes, sir.
Right. All right, so yes, they have a whole number part and a fractional part. But that would not really that is not really what makes them so special as fractions. What makes them so special is their denominators. Anybody know what the denominators are of decimals are?
Yes, sir. Starting from 10, 100,000.
All right, so their denominator would be in some powers of 10, right? Now, decimal is pretty much the system that we use when we're dealing with number. Even when you're counting, our counting has a decimal system to it. Because when we count to 10, and then once we reach 10, we start a new set of numbers. So we start repeating 1, 2, 3, 4, 5. Again, when we reach 10, we said we would have 11. But 11 is just 1 and 1. And we have 12. 12 is just 1 and 2. Do you get the idea what I'm trying to bring across to you guys? So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then now we would go 11. And then we have 12, 13, 14, 15, and so on. But what you notice is that you start repeating the numbers. So 1 now start to repeat again. So you have 1, and then 2, and then 3, and then 4, and so on. So once we get to 10, we just put a place value for the 10th. So in this case, when we reach the 10th number, the place value now for 10 would be 1. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the 1 now becomes the place value for the 10, and then we have 0. But when we continue counting 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, the place value for the 10th now becomes 2. And then we have a 0. And next now we go 20 and 1, 20 and 2, 20 and 3, and so on. So we are always counting in groups of 10, even in our number system. So it means then our number system is really a decimal system that we are using when we are counting. Is that clear to everyone? Raise your hand, guys, your hands. Let me see what is happening. All right. Now, so it should be clear to you then that the word decimal, all right, so these will be our objectives. So we should be able to define decimal fractions as fractions with powers of 10 in their denominators. And we should be able to add them, subtract them, multiply them, and divide them, just in a similar way as what we have done with the fractions. So decimal means 10, right? Because we often hear the prefix deci or decade, right? Because a decade would be 10 years. So anything you see with that deci in it would suggest that you're dealing with 10, all right? Now, in a fractional form, when we refer